All right, I have the pleasure of introducing the next speaker, myself. You may have noticed in the program there were more speakers. Unfortunately, they were unable to make it. So I will be the last presentation, and given the audience, we were hoping to kind of turn this into an open discussion after I give my presentation, because I think most of us, I presume, are educators or students of some kind. It would be nice to have feedback and just discussion of what's been happening over the past 2 years, in lieu of having the other 3 presenters who were supposed to be here. So, my name is Armen Amirkhanian. I'm an assistant professor at the University of Alabama, roll tide, and I'm going to be talking about experiential hybrid and online lab exercises. One of the big things with the pandemic going all online is, okay, what do we do with labs? I have the distinct pleasure of being the only faculty member in my department that has taught the only required lab courses. Maybe because I'm not tenured yet, they're like, oh yes, so we'll just shove it all onto him. I actually really enjoy it, but in March of 2020, as soon as the university was even talking about going online, I started to panic. I was teaching a summer geotechnical engineering course, which has a laboratory component. I was like, oh my goodness, how am I going to get these students to do anything geotech related? And then in the fall, I was teaching our materials course, which we cover a lot of concrete. How are we going to do this? So we're going to kind of cover this aspect of the online environment. And just as a show of hands, how many of you teach laboratory-based course? Oh, great. Okay. Some of you may come up with great ideas as well. So that's why I wanted an open discussion at the end, because just because I'm the person talking doesn't mean I have all the answers. And I like this photo in particular because the student shown here, and I went Megan Kaufman, outstanding student. I would never have even known she would have been outstanding had we not had this hybrid laboratory setup where she and other students would be allowed to kind of do their own thing. And we're going to get into that. And that's really at the heart of the experiential aspect. I would have just seen, oh, she got a good grade. She goes on to the next course. And that's it. So, speaking of experiential and kind of this educational aspect, my background's a little unique. I have a ceramic engineering undergrad, and then I switched to civil. So I am very much into materials. I tell my students, if you ever see me designing a bridge, don't drive over it. I do not do structures. All my emphasis is materials. And since concrete pavements are, they're like baby structures, not really. I do that too. But on the educational side, I was an experiential learning fellow at my university, and I'm also a certified online instructor through the Quality Matters program. Some of you may have heard of what that is. It's not engineering specific. It's actually like kindergarten all the way through college. And they have a pretty robust system in allowing or giving instructors the ability to teach effectively online. So I've done all of these things and kind of incorporated a ton of aspects into how to get these labs online. And the first thing we need to talk about is just because you are teaching a lab doesn't mean it's experiential. Yes, the student is experiencing something, but we need them to experience like learning, not, well, here's the recipe, please try and follow it, and you get what you get. Not really learning other than you're not a chef. So, and I'm going to pick on concrete mixing because this is the one that by far is the worst offender at being thought of as experiential, but in no way being experiential. If you give them the mixed design, say batch out 20 pounds of cement, 10 pounds of water, etc., give them the mixer, have them do it, they're not learning that much. They're learning how to follow the directions you gave them. They don't know that if they added more water, it would get more fluid. And then if you add too much, it's curbcrete. And if you don't add enough water, it just coats the inside of the mixer and never will come out again. So how do you take this idea of like you want them to learn, and hands-on learning, experiential learning is a very important aspect, but now we're kind of remote. And I will say, so I'm at the University of Alabama, no politics, but in the fall of 2020, the university decided that we will still hold everything, albeit hybrid. There were very few online only courses. There was not the biweekly testing that Illinois had. It was more of if you don't feel good, get tested. So we still had this hybrid aspect. So everything I'm presenting is in the context of still being able to do at least something in the lab, but not a lot, because we did have limitations on number of students in the lab. So thinking about mixing concrete and doing something with it, you're not learning a lot if I'm giving you the recipe. Now we can start talking about pedagogical theory. Can show this one experiential learning theory. Kolb has a theory. Not saying it's the best one, it's just the one that most easily translates to a nice PowerPoint graphic that I can, point to. But it does a great job of at least kind of separating out the components that make something completely experiential. And so I actually presented this experiential theory last spring at ACI when talking about how we teach non-destructive testing exercises to students. And so we're going to apply the same theory, but now to a more laboratory and hybrid scenario. So looking at kind of the first two components is this, I forgot. Laser pointer. Abstract conceptualization. Think of that as classroom learning, or the TA explaining in the lab what you're doing, like you're mixing concrete. At some point early on, the students do need to learn the process. And the way we've implemented it in this set of exercises is in the classroom, we first cover ACI 211. They go through a homework assignment doing it. And then, and this is the best part, I send them to the lab and tell them, mix your concrete that you calculated. Now, how many of you think that all my students got a 100 on that calculated assignment? I've seen all types of concrete, but it begins with explaining what concrete is and then reinforcing that explanation with a concrete, no pun intended, this is Kolb's word, concrete experience. It works nicely for this though, with an experience. But to get to that part, the experimentation, and this is the aspect that's missing from a lot of either in-person or hybrid labs, allowing the student to fail, to make that curbcrete, to make concrete that won't come out of the mixer. Because if they only see success, they only see the recipe in front of them and not learn why. Now, this is difficult to implement because either you as the instructor or your TA who's leading the lab needs to also have this mindset. That on the instructional side has been the biggest challenge. Finding a TA who can handle that type of teaching and not just, well, the lab manual says this. But if you allow them to kind of do something, anything really, I've told students that had concrete that was too dry, well, spray some water in. And after they do it, on purpose, I say, oh, how much water did you add? And they're like, well, I don't know. I was like, well, how could you figure that out? And a lot of them, with hints, will realize, oh, I knew I sprayed about 3 seconds. So I'll spray about 3 seconds into a bucket and just measure that. They actually have that capacity if you provide them the opportunity to experience it and not rigidly set the lab exercise. And then finally, in Kolb's theory, at the end of all of this, you do need to kind of reflect, allow your brain to process what you've learned. And, I have I have this picture because it's like, a PE exam. You're all sitting there taking an exam and it's really stressful. You're kind of reflecting on, oh, I should have studied way more for this. But they need some type of kind of post-exercise reflection. All right, so how does this work in, well, I don't want to say current because at least at UA, we are back to normal completely. We don't even take COVID excuses anymore. But for other groups that maybe have different levels of things, how are we going to implement this? Okay, so we're going to look at mixing concrete. Classroom, you learn about what is concrete, ACI 211. The active experimentation, allowing the student to do their own thing, or the group. Create a concrete mix that meets these set of criteria. The big one, and this is one lesson learned, put a limit on how much cement they're allowed to add to their mix. 300 pounds of cement for a half a cubic foot is not an appropriate amount. That is already way more than half a cubic foot. And so if you provide kind of those bounds, you'll guide them to kind of self-correcting their egregious mistakes. And then, and I purposely left it to this point, the experience. So you mix concrete, you cast a cylinder, maybe you do compression testing, flexural strength. Guess what I did? I had them make a panel, and then we blasted that panel with a 2x4 that was traveling at 150 miles an hour. Nice. That got them interested. What's not in Kolb's experiential learning flowchart cycle thing is the intrinsic motivation of the student. That's actually one thing I didn't even really think of until I took where I did the Quality Matters online instructional teaching certificate. You really need to provide that motivation to the student to want to learn. I mean, what student wouldn't want to make a panel and then blast it with a 2x4 traveling 150 miles an hour? That's a really big carrot to give the student. Some motivation to actually want to design a concrete mix rather than, well, I found this one online. And that's the thing. I told them they could find ones online if they wanted to. Oh my goodness. That's even more comical in terms of what they produce because, as I'm sure everyone here is aware, there's different aggregates. The aggregates in my lab are certainly not the aggregates in the online document they found from like California DOT on how to mix concrete. And so they get unusual results. But they're going through the process. They're thinking about rather than just simply following the recipe. And then after they blast it with a 2x4, well, I will say we purposely shot it at 150 miles an hour because we knew it'd fail all of their panels. But we wanted them to indicate why did they think it failed and what could they do better. So how do we do this in a hybrid setting specifically? Well, like I said, we have pretty much gone back to normal, but I have found that even though the attendance is expected in class, having students be strongly convinced to show up to class, I still record every single lecture and post it. Sure, and to your comment about getting students in the classroom, oh yeah, there are students, I should say this is a sophomore level course. They're it's an interesting point in our curriculum to have this course, but there's 90 to 120 students, and I maybe have 50 students show up to class. The others think, oh, I'll just watch the lectures. Some do okay. I'll give them credit. They study hard. Others, more often than not, do not, because they're missing out on that experience, not only in the classroom, but also the lab, because all my lab videos, and I'll get to that in a moment, are also pre-recorded. And I'll explain how we went through that process to add the hybrid portion. So they have that, and then we have the lab manual. And this is another key important thing to, well, I don't want to say fix, to think about fixing if you're teaching a laboratory course, because it ties into this active experimentation idea. My lab manual, it's 110 pages. I wrote it all so that I wouldn't have to deal with copyright and get in the bookstore to print it. They really check too. I slid in like a DOT like figure, and I said, oh, that's not yours. I said, no, it's okay. It's a state, it's not copyrighted. But since I wrote it as a narrative. It doesn't even have a recipe. And I'll get to in the end what one student in particular said about it when he didn't realize I was the actual professor. He thought I was the student. So I got a very candid response. But I don't have step-by-step. Nowhere in my lab manual for any exercise is it listed step-by-step. I'm explaining it in a paragraph form. A lot of students hated it first because they're used to chemistry and physics labs being do this, do this, do this. But then by the end of the semester, they realized they actually got something out of it. And the other thing is, allow them to make mistakes where the grade is not dependent on those mistakes. So when the group mixes concrete with a water cement ratio of 5 because they misplaced the decimal, that's fine. You're going to get the same grade as the group that mixed it correctly at 0.5, as long as after mixing it, you realize what your mistake was. You realized it should not look like water that has rocks in it, but okay, and you go back and you find your mistake. That is far more important than, well, professor gave me the mix he's been using for 40 years and it worked. No duh, because it's been mixed so many times. And if you reinforce the aspect or the fact that the grade will not be affected, they really actually will open up and try things. I will say it's really hard, though, to convince them that. They don't believe the TA, at least not my TA. I should explain my TA, just this will set the context. She was formerly in the Turkish military doing missile impact analysis for the Turkish military, and is a very strict and strong person who would give the impression that if they missed one little thing, they would fail the whole course. So I go in, and it's almost like good cop, bad cop, but go in and tell the students it's okay. It's okay. So these lab videos, and this is actually a screenshot from a video. This is not a photo. I have some background in filmography, and that shows how little background I have, because that's probably not the correct word. But I know enough, and I happen to have personally a nice camera that can do this stuff. I painstakingly recorded every single lab exercise that all the students will do, and not just from, well, here's the set up the camera, do everything in one shot, the end. Each of my videos probably has about 20 different scenes in it, even for like a 5-minute video. Set up the camera very carefully so they really see what they're supposed to see. This accomplishes 2 things. One, if the student cannot attend, either fall 2020 when we were severely hybrid, but still in person and got all the excuses, but they could essentially be as close to what I wanted them to see as if they were really there. Like I said, the camera angle does not stay here, and I didn't put the video in here. At the end, I have a QR code you can watch with the video and a bunch of others. But in the very next scene here, I actually like stopped the camera, moved it in really close so they could see the texture of the concrete. Because here, okay, you know it's concrete, but you can't quite get a sense for what it looks like. And these are sophomores, by the way, so hardly any of them have interned, co-opted, anything. A lot of them have never seen fresh concrete. So I tried, again, to replicate as much as possible that. Now that we're back in person, let me tell you, all hours of work. For instance, this lab video here is only 6 minutes long. It took me about 4 hours to film because I've set up lighting, I set up the scene, everything. But now I can use this still for the in-person labs, ask them to watch it ahead of time. And when they show up to lab, guess what? The TA who's ready to crack skulls doesn't have to say anything. They've seen the video using the equipment that they're going to use in lab, and they can go right to it. In fact, that's been one of the biggest things I've gotten feedback on is, thank you for doing this. Now I don't have to spend 2 hours in lab because I show up and I know exactly what to do, where to go, and I can get it done in 45 minutes. Never have I had labs end early until I did this, because I'm doing everything on the equipment that they're using. It's not some video from, no slight against Tyler Lay. He has a ton of videos, all on these topics, and they're great. But if they watch Tyler Lay's video and come into my lab, the specifics don't really line up. But since I filmed it in my lab, it works out really well. So that requires you to understand some aspects of actually how to set up scenes and stuff. This is very brief. I'm not going to go over this. I gave a workshop to faculty on Wednesday on how to shoot these lab videos in a professional style setting. And this is just one slide kind of giving you a tease on like things you should probably think about. 3-point lighting is probably the biggest thing. And using not a webcam. I happen to have a SLR camera that's pretty nice at shooting this. It lets you set up the scenes a lot better. But even if you're using a webcam, 3-point lighting will take your webcam from looking like a $10 hostage video to like, a semi-professional, description of what you're trying to get across. And that's just kind of what they're using in here. You go from just kind of the main light to a 3-point lighting setup, and it already looks just more professional. And the last aspect, and this is the second most thing I got feedback on, is the humor. I have lots of sound effects in my videos. I mentioned I know a little bit about filmography. I'm pretty competent in Adobe Premiere. I can do some really cool stuff, so I add a bunch of sound effects and everything. And please don't tell my department head I was doing all this instead of writing research proposals. But it really got them interested. They actually watched the videos. And I can see that because our LMS tracks every second they watch. And I saw they actually watched to the end, not jump around and try and figure out what the answer is. So taking time to set up these videos is important. You can't just go in, set the camera in one spot, do everything, and then hit stop record and expect it to be good. It does take a lot of effort. Now, switching kind of to the paper side, the narrative I was talking about, I kind of give some guidelines on what their mix design should be. I do let them go up to 0.9 water cement ratio, if they want to, just to have an idea. Because now that we're fully back, the students actually go look, because we have multiple mixers. So there's several groups mixing simultaneously. They'll actually go look at their friends. Go see how their mix is turning out. And if you're giving them a recipe, everyone's is the same. They never see anything different. So that's explained here. And then when we talk about specimens, again, it's not bulleted. It's not giving them step by step and then questions at the end. It's as if I'm talking to them. And I will say, initially they hated this because they had the 100-page lab manual and they were flipping through because they didn't watch the lab video. They're trying to figure out what to do. And it's not, oh, it's step 3 that they need to be at. No, this is just kind of a description. So feedback. This first one is from a student who didn't realize I was the professor. That shows how much he showed up to class, because he was talking to me about this. And had he actually been in class to know, oh, that's the guy giving the class, he's probably the professor. He probably wouldn't have said that. But he was upset because my lab manual did not tell him step by step what to do. He was pretty much the only one who was really upset about that. The other students were generally like annoyed, but after doing about 3 of these labs, they realized, oh, this is actually a lot better. They're actually remembering stuff, so when I ask it on an exam, they can recall it. Now, this next one, this one without context seems very odd. I mentioned humor. So one of the humorous things I did, I had this kid's toy, basically, that was a plastic finger just pointing. And occasionally, from off camera, I would like slide it in to point at maybe a sieve that I was talking about or an aggregate particle, to act in place of my finger doing that. And it not often, but enough that students started playing the game of every video trying to find when the little hand would show up. Again, something to motivate them intrinsically to want to watch the video. And then this is the biggest one. They can finish a lot quicker. Not only are they getting done faster, they're actually probably learning more than had they stayed there the whole 2 hours mixing a predetermined concrete mix. And then I did hear this fair amount, but what they did not realize was I actually told the TA, do not tell them, don't baby them. And she readily complied because she has that military background. She was like, all right, we're going to treat them like adults. But what I wanted to do was just, again, provide that motivation for them to want to learn. So that's the experimentation, the active experimentation side. And this can be done hybrid and completely online. So I did have students who either missed the lab in person or had a COVID contact that prevented them from attending that particular lab exercise. We didn't have the ability to make up labs due to the schedule. And based on test results, like exams and homework, they pretty much retained the same information as the students who attended lab in person with the videos as well. And it really goes to that aspect of designing the exercise so that the student actually gets something out of it. That's the key thing. It doesn't have to be concrete mix design. Like I said, I did this for the geotech course. I made 10 geotechnical lab activities in the same way, wrote another 100-page lab manual. Same thing. They actually retained stuff and remembered stuff even beyond the course. But then the experience. So here's a slow motion still from shooting a board at one of the panels. We also did thin brick facades with this. This is part of a PCI studio. So they cast their concrete and put the thin brick to make it like a brick wall. And we shot the board. Of course, students loved this. It was very exciting for me, for the students. But I was shocked at just the natural conversation that came up after, they watched, well, in real life, if they were able to attend, but also just the video afterwards. These are sophomores with no structural engineering course. The most they've taken is statics. A few, not a lot, but a few were on track to identify some shear failures. Now, dynamic impact is a unique field. It's not like, oh, I just loaded it slowly. But the fact they were starting to piece together things they had heard in other courses and try and think about it and apply it to something they're seeing with their own eyes, either on video or in person, was really powerful. Now, having said all that, and I'll get to it in just a moment, but this took a lot of effort. This is not trivial to do. In this course, there are up to 96 students that can enroll. In the geotech course I teach, there's up to 120. This may surprise you, but UA is top 10 for undergraduate enrollment in the country in civil engineering. Our academic ranking is not top 10, but our undergrad enrollment is top 10. We have about 800 or 850 undergrads in our program. All of them are required to take this materials course and geotech course. So those two lab courses that I get to teach are filled with people. This is not something that, you get to have the luxury of just having 10 students and really getting it. So how do you make it powerful? Well, you take this hybrid online style that we were forced to adopt at the start of the pandemic and continue that even as we come out. Like I said, last semester, there were no restrictions. I had 30 students in each lab section show up to lab to do these exercises, but I still kept a lot of that online aspect. It really enhanced the educational outcomes. And then reflection, the why, thinking about what they did and what they got out of it. And then for you guys, how do you assess it? Because if they do mix concrete with the water cement ratio of 5, well, are we just handing out gold ribbons to everyone who tried hard? Shouldn't there be some differentiation between a group or just student who from the start correctly did everything from someone who didn't? Well, it depends. If the student who messed up initially was intelligent enough to figure out their mistake, and this is a rhetorical question, but do they still deserve a really low grade? My view is if a student is able to determine their mistake and fix it, that's just as valuable as being correct the first time. Maybe even a little more valuable because they went through that process of problem solving and not just maybe by chance getting a correct answer. But regardless, this whole activity is not fully powerful unless you have them kind of review and go through what they did. It's so nice to just let them play in the lab, mix concrete, and grades don't matter kind of thing. Well, they do, but how do you structure it? Well, asking the why. So one thing that I've done at the start of the pandemic was we don't write lab reports anymore in the traditional sense of abstract, experimental procedure, results and discussion. They, for each of these activities they do, submit what I would call an engineering technical document. I tell them if you were a consultant being paid to, and no one pays people to do this, but if you were paid to do a concrete mix design, you should be able to give me all the relevant information of everything you did in a couple of pages. very succinct, and demonstrate to me that you understood the process. So not just one table that says, 800 pounds per cubic yard cement, this and this, but also not saying, step one, we first weighed out the water. But I assumed you weighed out the water when you mixed the concrete, so I don't need that level of detail. So we kind of struck the balance of what they're reflecting on. In my opinion, they're reflecting on the more important aspect is of the individual activity, what they physically needed to determine, and then what they observed after they performed said activity. In the sense of, let's say, a sieve analysis. Well, they needed to know what sieves, get all the weights, perform calculations, and then observe the gradation and comment on, well, is that uniformly graded, poorly graded, what do you have? And not tell me in step-by-step traditional lab assessment, well, I first stacked the sieves, I then did this. The nice thing is it makes grading so much easier. Instead of these 15-page lab reports where they're copying and pasting from their friends with the abstract and experimental procedure, I now have 2 to 3 page technical reports that honestly are probably a little better written because we're not asking them to write pages and pages of just what they did. And I can really get a sense on what they understand. But again, it takes time and effort. So that's kind of been the experience going from completely online that very first summer to then immediately hybrid, and then now back to normal with laboratory exercises. Lots of video editing, tremendous video editing. And this is the last slide. It's a QR code to the video with all the slow motion, debris cannon stuff. You can watch it if you want to. My tethered cell phone couldn't download the video to do this. And you can email me and I'll be happy to share it with you.